9. Hello, everybody. I believe we are live. I'm very happy to have you all. My name is Jan. I'm heading up marketing at Imagely, and I am joined today by a very rare guest, by our CTO, Malte Baumann. And yeah, we have the pleasure of introducing the CSDK Renderer, our most recent release and addition to our creative automation solution. First, let me do some housekeeping here. As some of you may know who have attended webinars in the past, we'll try to keep the presentation portion to a maximum of 30 minutes, maybe a little less time, because we want to allow for more time for questions, seeing as this is a entirely new type of solution, and we're very hungry for your questions and feedback. So do use the Q&A function of the webinar studio here, so I can collect questions while Malte is presenting, which I can then relay. Of course, the recording will be made available together with the slides. So real quick look at the agenda. We're going to talk about the renderer, what it delivers, what challenges we set out to solve. Then Malte is going to walk you through the architecture, how it works, some use cases. Seeing as we don't really have the visual component here, it's not going to be a demo per se, but it'll give you a very good understanding of what is possible with the renderer. All right, for those of you entirely new, we are Imagely. We bring creative editing to any app on any platform. So anything from classic design editing or photo editing to video editing, creative automation, and now also AI-enabled use cases. We serve over 500 million video photo creations every month. This figure is probably due for an update if we include automation, but that's just very briefly about us. We are about 50 team members, distributed worldwide, entirely remote since at least COVID days, I think. Now, before I hand over to Malte, I included a summary slide for your reference to just really hone in on what we provide with the renderer and where it fits in sort of the landscape of our solutions. So the renderer, as the name suggests, it allows you to render designs into images and PDFs, and most importantly, we have a high-performant and patent-compliant video actions. To anyone who's been interested in using CSDK to render videos knows that this is a client-side feature only currently, unless you are willing to engage in some very complex workarounds. But now you do get a Docker container, which enables you to generate any type of media that you're used to generating on the client with CSDK with full fidelity now on the server. And it removes also the limitations of like Node.js, where you of course have a single threaded environment without GPU acceleration. So if your use case involves like large scale personalization, creation of variation in ad tech or print, and you're also reliant on having a really high resolution and bigger files, then this is we developed this for you. And with that, I sped through this because I want to clear the stage for Malte, and he's going to take over explaining a little bit about what the CSDK engine is, what our architecture looks like, so you have a better mental model to understand how the renderer fits into this.
All right. It's a little weird to see nobody else, but I'm just going to talk to Jan and give you all an introduction. Jan gave most of the overview away, and we are starting with the engine because it's essentially the core part and also what the renderer in the end ships under the hood. Our engine is our workhorse. It does all the state management, all the input handling and rendering. So it is what you may use to do design editing, everything that you can do with our editor, but in an isolated fashion and as a standalone thing that we share across all our products. So whenever you see an editor, a script running on a server, it's always the engine under the hood somewhere. And that's also one of the main drivers which allows us to do the things we do. We can do exactly the same design across all platforms, use the same shared core for that, and use that engine mainly in this case for automation cases. So imagine you have a template, some kind of thing that you want to fill with your personal data. That could be a list of addresses, as you can see in the picture here, a list of different house offerings. You can use the engine to fill the template and render out all the different files you need to start your campaign, send out your flyers, whatever it may be. And that engine is just our core. It's the logic that we ship everywhere, and it enables this rendering. To understand that a little better in context, the engine is all the way down in every product you see, and you usually interact with our UIs. So that's what you see at the top right here. We have UIs tailored towards photo editing, UIs tailored towards general editing, but it's any app that uses the engine under the hood to do all the drawing, rendering, things you see on screen, editing elements on screen. That's what we ship for different platforms, for different environments. And most importantly, what we always ship for the server already. So we do have a Node.js binding for the engine, which allows you to use it without a UI on a server to do editing of scenes. So for example, the text replacement you saw in the slide before. And the renderer now takes that engine to the next level and brings it to new places that I'll show you a little later. The one we had on the server is the Node.js binding, and that is essentially the engine variant that runs in your browser, packaged a little differently so that it can run in a headless fashion. So you don't necessarily need a browser window or some visual representation to use it. You can just spin up the engine in a script on a server somewhere, load a scene, modify it, do all the things you can do with our web APIs with a few limitations. And these limitations are essentially the main drivers that caused us to go for the renderer. And those limitations are, first of all, Node.js is entirely virtualized, so you don't have direct GPU access and some limited resource access that slows down everything. Quite simply, slows down everything. So while you can do image editing or image rendering on Node.js, it is slower than what you would see in your browser, because the browser has access to all the system resources and can do things much faster, and we can use the more fancy technologies to do things faster. We had customers work around this limitation already through virtualized Chrome instances, so essentially set up a fake browser in a cloud somewhere and do all the editing there. But this is a very brittle setup because you have to make sure the environment is always up to speed, works well, and it's also never as fast as something native which has direct access. And then there comes along the biggest limitation so far. On Node.js, we can't do any video encoding yet. And that's mainly due to the limitations of Node.js, but also due to the technology stack we can work in on browsers. Browsers offer the video web codecs API, which essentially hands us the entirety of video encoding and decoding. And Node.js straight up doesn't have this route. So that we, up until now, were unable to offer video encoding on servers. So if you wanted to do any automation around video scenes through Node.js, you were out of luck. And this was the biggest downside we had so far. And the unfortunate part that comes along with all this video stuff is patent handling. You're all aware that video is around for a while, and unfortunately, back then, or very fortunately back then, lots of smart people had great ideas how to efficiently put video data into files and get them out of there again, which led to nowadays or today's video codecs, mainly H.264 and H.265, being heavily patented. You can find various implementations of those codecs, but because they are still patented, whenever you redistribute such a codec, so that could be you shipping it as part of your application in a browser window, that could be you shipping it as part of some server application you're using, you have to make sure that you're legally compliant and comply with patent laws and cover all the patent fees and patent pools. Up until now, this was not a concern of ours because the Web Codecs API is essentially using the browser's codec implementations, and the browser or system companies are covering these codecs. So for Chrome, Google covers these codecs. For any Apple platform, Apple covers these codecs. But with the server side of things and Linux, where none of that is covered, a new dimension comes in. So we wanted to make sure that customers of ours don't have to worry about, am I using something in a gray area? Am I using something not legally safe here? And that's why we decided to partner with Fluendo, which is a company specializing in exactly this fun field of video codecs and video implementations. And they are making sure that the pipeline we provide to you is legally safe and all the patent holders are aware of it, get their share of things and everything in a way that you don't have to care about it. You can get a license from us. We will make sure that we report everything properly, and video codecs are none of your business anymore. They just work in the renderer. And with that, let's take a quick look at what it means if things work in the renderer. No questions so far, so I'm gonna just go ahead and do a little more hands-on things. Okay, show and tell game. I will cover our two default use cases. So the first one being you as a user, open your browser and do some editing. I'm not sure if you can see. Yes, you can see my mouse. You do some editing in your browser. You edited an image. You created this fancy tropical vibes and stand up in front of a mountain range. And you want to now get the image out of there and send it off to friends and family, web campaign, whatever it is. So you hit the export button at the top right. Within the browser, we are doing the export. We are generating the image and saving it to a file. And you can send around that file. That's our bread and butter default case. That could happen in your browser. That could happen on your phone through one of our UIs. That could also happen in your very own custom UI. It's set. A variant of this is the automation case, which is essentially the same thing, just that you don't create the scene using your mouse or your keyboard or whatever, but you're creating the scene using some kind of script. That script would create a new page, add an image, add a text block, but in the end would again hit some kind of export trigger, which creates the image. And this is what we call automation. This could happen again in your browser, maybe somewhere in the background of your website, in the case of you creating a preview image for some user somewhere, or for the more normal case, somewhere on a server on some external trigger. Maybe every night you create 5 different scenes with different vibes and try to save them to an image. And these two cases are already 100% feasible. They work fine. You have this export thing here. You have this export thing there. But they could be better. For example, in the editing case in the browser, it's often that you don't want your users to wait for things. So you wouldn't, for example, in the case of you doing a big image, you might want to offload that export already to a server and let your user continue editing without waiting for that export to finish. Right now, this is a blocking process and you have to somehow wait for things to wrap up. Or if we come to the more tricky world of video, things just become more complex. Video is a massive increase in data compared to a single image. Suddenly you have a series of images. A video might be a few hundred megabytes. You are pulling in more and more other data. So the export process starts taking longer. the user needs to wait longer. The need to offload that somewhere is becoming higher and higher. And again, now we're coming already into the limits of the Node.js package. So if you want to do automation on a server with video involved, you're out of luck right now. The Node.js binding will only enable exports of images. And if you want to export an image, a video from your scene, there's nothing you can do right now other than working around it in a weird way. And we can go even further. Let's assume you don't just want to create one image or one video, but variants of images. Remember the slide before where we had multiple ads for different houses? You can do the same thing for videos. There's the need to create various variations of the same template in video. And now it gets to the point of, okay, this is unrealistic to do in a browser window. I don't want to force my user to keep open the browser window until I have rendered all 50 different variations of that video. I don't want to let someone wait for the 200 ads to different social media networks that I want to create. And this is exactly where we targeted the CSDK Renderer for, because it can replace all these slow and expensive, or mainly slow processes in your browser or in automation. The renderer is a very specific tool in the sense that it takes a scene or an archive that was created either in your browser through CSDK or through a script, again through the engine, and just exports that to whatever format is specified. So you can load a scene and export the corresponding image. You can load a scene and export the corresponding video. But compared or in difference to the Node.js package, it does that across all the formats we offer, and it does that in a very fast way because it's directly GPU accelerated. It runs natively on Linux hardware, and it's just the missing piece in our ecosystem, which enables you to cover more advanced use cases, but also very fundamental paths. And how it does that is that it runs in a Docker container, so you can deploy it in your infrastructure wherever you need it. That can be, you have already something set up on AWS, you have some kind of cloud infrastructure. You just spin up an instance of the renderer and feed it with scenes, archives, whatever it is. And the renderer then takes care of processing things and hands the resulting file back to you. I do have a few tiny examples right here. So the basic case would be, and I just noticed that it's called processor in here, but it's the renderer now. A scene is our representation of a design you see on screen with external references. So a scene doesn't contain all the data, but would just point to the images somewhere in your S3 bucket or some cloud storage. And an archive is the same thing, but combined with all the archives. So you can decide if you want to send just the references and the renderer will take care of downloading things, or if you want to send a self-contained archive where you can be sure that this will be having all the assets already included. Those get sent to the processor into the Docker container and rendered to a video or an image. And in the case of a more advanced pipeline, you could do the same to, for example, going back to the example we had before where we have these different house templates, you would have that scene defined with all the placeholders in place. So you have 3 images and some text. You then use Node.js to replace the images and replace the text and create different variants of that scene, and then hand all of those to a renderer instance or multiple renderer instances, depending on your time needs. If things need to go really fast, or if you have some time to chew through all the different variants you want to create. And again, in the end, you get a video variant of some sort or an image variant and can save it to a bucket, feed it back to a user, whatever you need. And that's where I would stop with my how to do things, because now it gets into the realms of it entirely depends on your use case where the renderer makes the most sense. The main benefits nowadays are, first of all, server video is the first time ever that we can ship something like this. And generally, it's straight up faster than Node.js in every way. So if you saw cases or see cases where performance is an issue and you need to have things ready fast, the renderer will come in and do things that Node.js took 30 seconds, the renderer will do it in 3. So it's a massive step up. And yeah, I think we can start with Q&A.
Brilliant. Thank you, Malte. That was great. Was I drinking from a fire hose a little bit? Awesome information. Mark has a question. Oh no, it's David. One of the two. So what kind of pricing models applies for the Fluendo codecs license? And here, just a peek behind the curtain for us, how we're handling licensing, but there's nothing on your end to be concerned with. It's entirely handled by Imagely. Malte, is there more to the licensing of the codecs?
Yes, so we currently offer 2 variants of the whole renderer. There is an open source version, which essentially uses open source codec implementations, which would be, in the case of video, not legally safe in the sense that you're allowed to redistribute those to your server. But we wanted to offer an option for trialing without going through the entire licensing hassle. And if you're just into images and just into PDF creation, for example, you don't need to worry about video codec licensing at all. If you go for the AV licensed version, how we call it, there will be a fee per instance of the renderer that's active. That fee is currently in negotiations, so I don't want to give away anything wrong, but it's some kind of limit that you can set up and say, I want to spin up at most 5 renderers at once, and I will pay a certain amount of money per renderer instance. Currently, we are, I think it's 3 digits, but I have to check with Harry where we are on that. But that's the licensing model. And that's entirely handled by us, so you don't have to get in touch with Fluendo in any way. You just, we forward everything to them and deal with it. And yes, again, it's per instance. So it's the number of containers you decide to spin up, the number of however you decide to set it up. And on our end, we allow you controlling in our dashboard how many maximum instances you want to allow. So you can be sure that there's not an accidental spill of, I just spun up 200 containers and my bill is going to be endless. We help with that and try to make it as easily handleable as possible.
There's another question by Philippe regarding multiple instances in a Kubernetes node group. Will the license be charged per instance? And the answer there was yes. I think Malte just went into it. Ole is asking, what can the renderer do that Node.js can't? Is it just performance? So speed?
Especially compared to Node.js, it's actually one thing in both directions. The renderer can't do what Node.js can in terms of API. So the renderer doesn't offer the extensive engine API that you can use to modify scenes. But the renderer can do exporting way faster than Node.js, and it can do exporting of video, which the Node.js package can't do at all. So it's win some, lose some, essentially. You can't use the renderer for all your scene editing needs, but you can use it for really fast export. And right now I have to still use Node.js for all the automation things and exporting to images, if that's fast enough for you. And then I can just go through the chat as well. Going in for Paul, and exactly as you mentioned, it would be for a simple setup. There's a license fee for the CSDK itself, and I would have to check on our actual licensing model right now. I think we go for the license for CSDK and with a default set of instances that are included. And then we can see how things would scale if you need more instances or if you want to expand usage or things like that. And we will soon offer a demo which covers exactly the case of that Paul describes, where you have the editor on a website and the export sends off things to a single instance of the renderers running somewhere in the background, because that's something very common and a useful use case we can imagine will happen quite often. And Mauricio is, there is a quite extensive documentation that we will share in the end regarding requirements in terms of hardware. To put it simple, it's NVIDIA. Anything you can get there that has video codec support will greatly help accelerating. We do, of course, also use CPU-based implementations and maybe the Intel QuickSync things. But it's the closer you match the requirements the docs specify, the better it is in terms of performance and the more optimized everything is. But it's the whole world of video codecs is a wild world in terms of requirements. So I would just refer to the docs there. Now we're at the end, I think.
All right. Yeah, looks like for all the questions. If there's one more, Francesca.
Excellent question. I would have to check on that because we license per platform, and technically the renderer is a new platform, but we can figure that out.
All right. Yeah, I'll save those questions as well, and we'll follow up individually. You can also, I'll put you in touch with someone from the sales team. They have more insight into how all of this works. And in general, if anything comes up, simply reply to one of the emails we send out, or get in touch directly with contact at Imagely or sales at Imagely. We'll catch all of that. All right. Thank you very much, Malte, for your webinar debut. It's probably going to be a rerun in 2 weeks since we accidentally, not so much by accident, but we put this on a Thanksgiving. So we had like one Europeans and Asians only kind of webinar. Americans have to watch the recording, but there'll be a rerun soon. You'll be notified of that as well. And in the meantime, if you have any questions, simply reach out. Okay. And with that, have a good one, everyone. Bye.
Thank you.